Hello and welcome to our problem solving session in geometrical optics. Today I will describe you with few best practices and methods you can use to solve any IIT JEE problem without getting into any difficulty. So the idea is that first we think about how we are going to solve that particular problem, then try it out and how we can handle complex situations with ease and mistakes to avoid. So we are going to solve about 5 problems today. So let's get started. So this is JEE 1993. Uh, Two thin convex lenses of focal length f1 and f2 are separated by a horizontal distance d, where centers are displayed by a vertical separation delta as shown in the figure. Taking the origin of coordinates O at the center of the first lens and xy coordinates of the focal point of this lens system for a parallel beam of light, find where the image will be formed for the parallel beam of light, right? So here the first thing is that they are already defining the coordinate system, right? So here is our lens number 1 and they are saying put a 0 over here and this is your x-axis and this is your y-axis. Okay, so any calculation you do has to be from this reference frame. Okay, so whatever image formulation wherever it will form, we have to write our answer in this unit. Okay, so suppose it is forming over here, so this will be the x coordinate, this will be the y coordinate, right? So that is the first thing you have to take into account. Now, second, when you look at the question, it looks very complicated, right? But eventually, what we have here is a two lens system, right? So we have a lens number 1, okay, and then the lens number 2, and eventually, fundamentally, what will happen? The lens number 1 will process the image, and whatever. So here is an object, right? From lens number 1, it will pass. It will make an image, and this image is going to act as an object for the lens number 2, and then we will have final image, right? So that is very clear, right, fundamentally. So that's what we are going to do. We are going to first calculate the image location for the lens number 1, then use that location, right, as an object for lens number 2, and then we'll know the final image coordinates. Okay, and we have to finally express our numbers in this coordinate system x and y, which is given, right? Now, as they are saying the first lens, the rays are coming parallel, so they are simply making it very simple. For a convex lens, right, it's a convex lens, positive focal length, rays are coming parallel, so definitely it is going to meet at the focal distance here f1. Okay, so now we have already solved the first part of it, right? So we know where the object is going to form, right? It is going to form at f1. So here is our lens number 1. Okay, lens number 1, and from here at a distance of f1 the image will be formed, which will be used by lens number 2. Okay, now it says that d is less than f1, which means that the lens number 2 is somewhere around here. Okay, this is our lens number 2, which is at a distance d from here, right? Okay, so this is going to be our object for the lens number 2, and it is also sort of not on the same line but higher up little bit. Okay, so we are going to use this principal axis for the lens number 2, and whatever the image is formed over here will appear to as an arrow or something like an object of extended dimension for the lens number 2, and we are going to do all the calculation from there, right? And this is given to be delta. So by shifting the lens, nothing happens. If the lens was just here like that, right, and the object was here or here, then we don't have dimension of the object. We just shifted this lens upward, which means nothing much. Basically you now have a dimension of the object, right? Nothing else. We shifted the lens, the principal axis is here, now you have an object with a dimension. That's all. So with that, let's try and find out the numbers, right? So for the lens number 1 we have already solved. It is going to be at a distance f1 and d is less than f1, so it is on this side, right? So here we have our diagram. First let's draw our diagram. Okay, this is lens number 2, this is the principal axis, and here is the axis of the lens number 1, somewhere around here, right? The lens is cutting like this. Now from lens number 1, this is the distance d, and it is formed at a much more distance at f, right, somewhere around here. So the object is for the first lens is located here, which will appear for this lens number 1 like this object of extended dimension. Hence this distance is going to be the u for the lens number 2, right? So we are going to write down the u or object distance, and this is going to be f minus t. Okay, so this is the total f, right? The focal length of the lens was minus d, and this is going to be positive because it is on this side. Now the ray of light is going like this, so always draw that to avoid mistake. This is positive side, this is negative side, right? So the u is positive. Okay, so with that, now we'll simply write our formula. So 1 by v minus 1 by u is going to be 1 by f2 for the lens number 2, and the final image v is going to be 1 by f2 plus 1 by u, right? I'm taking that side. With that, very simply you can come here. So now plug that in. Basically 1 by f2 plus 1 by f1, which is the f1, yeah, minus t. Okay, so now that is going to be our 1 by v. So we solve for that. It's going to be f2 into f1 minus t. This will go on the top. F1 minus t, f2 nicely be f1 plus f2 minus t divided by f2 into f1 minus t, right? And this is our 1 by v, remember that. So you can make a mistake, like you can take the v as like this one, but don't do that, right? So the v is f2 into f1 minus t and divided by f1 plus f2 minus t. Okay, now we know that this v is from where, right? It is from this lens. Okay, now we want to know it is on the left hand side or the right hand side. We can simply look at this expression, and we know that f1 and f2 is greater than d, right? So this is positive, and this is also positive, so the v is positive. Okay, so it is going to be on the this side from the lens number 2. Okay, so our v is going to be somewhere around on this side from the lens number 2. But remember, we have to express our answer in the coordinate system which is given here, right? So now we know that here is our lens number 1 and here is our lens number 2, right? And the v is somewhere around here, right? We know this distance b, and between the lens the distance is d, right? So to find the x coordinate of the final image, basically we'll have to say x is equal to v plus t. Okay, that is very clear. And we will first, what we'll do is that we will basically just find the x first and see if we can, we have an answer, and if not, then if required only, then we'll find the by. Okay, so with that in mind, let's proceed here. So this is our v. Okay, and we are going to find the x coordinate. X coordinate is going to be f2 into f1 minus t divided by f1 plus f2 minus t plus d. Okay, plus d into f1 plus f2 minus d. That is going to be f2 f1 minus f2d plus df1 plus df2 minus d square divided by f1 plus f2 minus d. Now while solving, we can always look at the available answers for the x, and we can see that f1 plus f2 minus d is for the 3 of them, right? So we are still not there. If we find the top one, we will be able to eliminate. So now we already eliminated a, right? So a is not going to be there. So now let's see and move on and find the exact answer. So in here now, f2d, this one will cut. Okay, so this is going to be f1 f2 plus df1 minus d square divided by f1 plus f2 minus d. f1 f2 plus d is equal to f1 minus d, f1 plus f2 minus d. Let's look back what we have got here, and we have it in number 3, right, which is the same expression. Now we also have it in number 4, right? So we have to choose between these two. Now, remember as I said, now the lens is shifted like that, right? So the image is definitely not going to be formed as 0, right? Because this is the optical axis. So it is going to be formed somewhere around here. So let's say the ray of light is coming like that, and then focusing here, then this is the object, right? Then we can see that image will be formed somewhere around here, right? So after it passes through this parallel ray for this one, cutting on this focal length, and this to center is going to cut, and then the image is going to form, right? So it is definitely not going to be formed over here, right, on 0. So this is not an option, so this should be the correct answer. You can always find that out now, because we have V and U, right? So and we can find using simply magnification is equal to V by U, and that is we have a ratio of V and U, and then we can simply find the heights, right? So magnification is here nothing but the height 2 divided by height 1, right? Height 1 is given to be delta, and height 2 we can find out, and M is also equal to V by U. We also know V by U, and when you do that, basically we'll arrive at this one, right? So because it's the objective question, I will not make that effort and basically click on C and move on. Okay. So it is also always important to not get sort of worried that this question is looking tough and all, right? You can, by simply using this fundamentals, you will be able to solve all the problems, right? So let's look at another one. Here we have two identical glass rods, S1 and S2, with refractive index 1.5. Have one has a convex end of a radius of curvature 10 centimeter, right? So we draw our own diagram. Okay, so here R is 10. Then we have another one here, because they are identical, right? This is also 10 centimeter. Refractive index is 1.5, and this is 1.5. Okay, they are placed with a curved surface at a distance d. So here is d shown in the figure with axes so on and so forth. When a point source of light P is placed inside the rod, okay, inside the rod at a distance of 50 centimeters, the light ray emanating from it are found to be parallel inside the S2, right? So something happens, so object is here, the first image is formed, and finally the rays are parallel inside this one, right? So the refraction is going to happen over here, and then it is going to be parallel. Okay, so very simply we are going to proceed with the fundamentals without applying any formula. Whenever you have a situation like this, it's always better to proceed with fundamental. So our strategy is very simple. We are going to use this object, okay, find where the image will be formed, right? So this is our surface number 1. We have an object, we know the radius and refractive index, okay. Some image will be formed, and then this image will be used by surface number 2, and then the final image will be formed, right? So this image will act as an object for this one, and the final image will be formed. Because it is parallel, that V is going to be infinity. Okay, as simple as that. So we are going to simply apply our general formula, a standard formula for refraction, and let's see where we can get. Okay, so first for the surface number 1, we'll always draw this diagram because it will help us get the sign convention right. Now here the object is this side, right? So ray of light is coming from the object, so this side is going to be positive, this side is going to be negative, right? Now this side is going to be N1 and this side is going to be N2, okay, and this U is 50 centimeter because to the left hand side, right, it is going to be minus 50 centimeters, okay. And now we can write the value of N1, which is 1.5, and N2 is the air, so it is 1, right? And now the radius is falling on this side, right? So radius is how much? Is 10, and this is going to be minus 10 in this case, right? So use that in our formula and write our first equation. So we are going to write our equation is N2 by V, N1 by U is equal to N2 minus N1 by R. Okay, so N2 is 1 by V minus N1 is 1.5 and U is minus 50. Okay, and this is going to be N2 minus 1.5 by R minus 10. Always remember, never try to directly plug in mentally here. It's always better to write it down to avoid the mistake, right? So that's why I'm putting an effort to write that down, right? So it is minus 0.5 by minus 10, minus will cut. So basically you have 1 by 20 here, okay? And now 1 by V So now we have 1 by v minus 1.5, and this minus minus will plus now. Okay, so plus 50 is going to be 1 by 20. Okay, so take it on that side. 1 by v is equal to 1 by 20 minus 1.5 by 50. Okay, and now let's solve that. We can do it 3 by 2. 100, 5 minus 3 b minus 2 by 100, that's going to be minus 50 centimeters. Okay, no, not minus, 5 minus 3 plus. Okay, so always take care of the sign. So this is 50 centimeters to the right from here. Okay, so our image will go like that, and always we know that it's going to form on this side, right? It is going to be now 50 centimeters from here. Now we don't know d, right? So whether this surface is here or here, we don't know, right? But all the options are given like 60, 70, 80, which is more than that, right? So which means that the second surface is actually distance from here, right? So now look at the second surface. We'll write down the equation and we'll be able to arrive at the answer pretty quickly. So here it is. Forget about the surface number 1. Now we have surface number 2. Okay, and the object is at a distance in here, right, which is total is d, right? So that d minus 50. Okay, and this is minus, u is minus. Okay, here. Now this is the way ray of light will go. So this side is now positive, this side is now negative. Okay, so n1 is 1, n2 is 1.5, and now the radius is on the positive side, so r is going to be plus 10, right? What is given? Yeah, 10 centimeters, and this is going to be positive this side. Now we are going to know that the ray of light is sort of becoming parallel here, right? So the v is infinity. Yeah, so now with that, let's write down our equation. N2 by v minus n1 by u is equal to n1 minus n2 by r. N2 by v is infinity, so this is going to be 0 simply, minus n1 is going to be 1 by u minus, okay, and then minus, this is minus. So let's find the u first. Okay, once we find that u, we can simply plug that one in here. Now n2 is 1.5 minus n1 is 1 by r. R is this time positive. Okay, so plus 10 centimeters. That this is now going to be equal to 0.5, 10, 1 by 20. So u is minus 20 centimeters. Okay, so u is minus 20 centimeters, which means the final object was basically somewhere on this hand side, right, on this side at minus 20, right? So it is 20 centimeter from there, right? The image, and we also have the equation for the u, which says that, where it is here, so u is d minus 50, it is given, right? So just plug that in here, and this is going to be minus u, right? So minus minus plus, d minus 50, and d is going to be equal to 50 plus 20 centimeters, and that is going to be 70 centimeters. Okay, so sign, it was saying that you have to just add that up. So d minus 50, right? So this is a distance which is d minus 50, and that is going to be equal to 20 centimeters. Okay, so if there's confusion, let me clarify. So this is the second surface, right? And we know this distance is d minus 50, and we also found out that because that u is negative, so this distance is also 20 centimeters. So simply d minus 50 is equal to 20. Okay, take that on that side, add that up, 70 is the answer, and that is option number B. We'll go with that. Okay, now let's move to another problem. It says that find the focal length of a lens shown in the figure, right? The radius of curvature of both the surfaces are equal to r, right? So radius of curvature r is given, and now you have this refractive indices varying, right? So when you have a situation like this, never try to use the formula, right? Because you do not know, you will always forget what under what condition that formula was derived. So we are always going to go back and basically use the fundamental equation of refraction, and this is going to be very, very simple, right? So focal length, so it means that the ray of light is going to come like this, and finally it is going to meet somewhere, right? And that is going to be the focal length of this, right? So if it is converging, so u for the first surface, so we are going to do the first surface equation, right? First reflection will happen over here, surface number 1. For that, u is going to be negative, or infinity, and then for this one the v is going to be f, and finally we are able to find the solution, right? So very simply, let's write down the equation for the number 1. Now this is mu2, this is mu1, right? I'll just draw very quickly. The ray of light is going like this is positive, this is negative, right? So our u is minus infinity, okay? And this radius is falling on this side, so r is positive r, okay? And this is going to be n1, this is going to be n2. We'll write n2 by v minus n1 by u is equal to n2 minus n1 by r. N2 is mu2 by v minus mu1 by u is infinity, right? So it is going to be 0. So finally n2, which is mu2 minus mu1, and r is positive, so let it be r, like that. Very simple. So now we have this equation which says that mu2 by v is going to be equal to mu2 minus mu1 by r, because 1 by infinity, that's going to be 0. Now let's write down for the surface number 2, right? So again like this time it is mu3, this is mu2, right? Ray of light will come like that, this is positive, this is negative, right? R is going to fall on this side, so R is again positive, okay? And we don't know the u, so we'll just take that, right? So we'll write mu3, right? And the v is going to the focal length, so it is going to be on this side, right? So v is positive, so we'll say f minus mu2 by u, right, which is this distance v2 by v, and this is going to be equal to mu3 minus mu2 by r. Now this is same, we can simply substitute this over here, okay? And with that will cut, and basically what you will get is mu3 by f, right, is equal to mu3 minus mu2 by r. So we'll go on that side and basically add up, right? Add up mu3 minus mu1 by r, so mu3 by f, and f is going to be mu3r divided by mu3 minus mu1, and that should be our answer, okay? So you see, we didn't try to use any formula for the lens or lens maker formula here, because the refractive indices are varying, and that is what is getting tested, that can you sort of apply the fundamental laws and fundamental formulas to solve the problems. Now here it is, the next one. A thin bioconvex lens of refractive index 3/2 is placed on a horizontal plane mirror as shown in the figure. So it has a refractive index 3/2. The space between the lens and the mirror is then filled with water, right? So we fill that the water with refractive index 4/3. It is found that when a point object is placed 15 centimeter above the lens on its principal axis, the object coincides with its own image, okay? So let's draw that first. So here is our lens. Now it is filled with water. Basically now we have two lenses, okay? This is lens number 1 and this is going to be lens number 2, okay? And object is here, and when it happens, the image of the object coincides with it, right? Finally, after this and this, let's not forget we have a plane mirror here, okay? On repeating with another liquid, the object and the image again coincide at a distance of 25 centimeter from the lens, right? So find the refractive index of that liquid. Now it is a difficult problem, right? Because you have a lens, you have a water lens, and then you have a mirror, right? So think about that. Here is our lens number 1. So ray of light is going to come like this. then the reflection will also happen through this lens number 2, then it will get reflected from the mirror, then it will pass again through this lens, right, and then through this lens, and then it is going to meet over here. Okay, now because the object distance and the image distance is coinciding, right, so for this system, right, this is same, which means that, you know, this f is going to be, for the combined system, right, it is going to be the same, right, and basically what will happen is that when of, let's draw the ray of light first, right, it is always helps that, you know, you do our drawing first, right. So first thing first, here is our object, here is our lens number 1, here is our lens number 2, and then we have a mirror, right. So ray will start coming from here, okay, then reflection will happen, finally it has to reflect it back perpendicular to the this thing from the plane mirror, so that it can go back to the place it was where the object will be formed, sorry, the image will be formed, right. That is the only condition which can meet, which means that the focal length of this lens plus this lens number 2, right, lens number 1 and lens number 2 is going to be equal to 15 centimeter. There is no doubt about that. Then only the ray of light, right. So this is our lens number 1, this is lens number 2, object at a point source at a focal length, right, f, so then it will come out parallel, get reflected back, okay, and then again the image will be formed over it. That is the only condition in which the image will be formed, and with that we are going to proceed. Okay, and similarly they say that now we change the reflectiveness of lens number 2, we'll call that lens number 3, and then basically again the focal length for the combined system is going to be 25 centimeter in that case. Okay, so let's try and write down the equations. And if you do not draw the ray diagram, basically will get stuck thinking that, you know, you have to apply the lens maker formula and whatnot, right. So let's say the power or power for the lens number 1 is P1, right, and power for the lens number 2 is P2, right, and that is, or we can say focal length for the lens number 1 plus focal length for lens number 2, and that is going to be 15 centimeters in the first case. Okay, and let's say the focal length number of lens number 3, when we change the refractive index, is different, right. So now we have focal length of lens number 1 plus focal length of lens number 3, and that is like this, okay, in centimeters. Okay, now we don't know radius of curvature or anything, but we know about this lens, right. So we can write something like this one. So for the lens number 1, okay, we can write the lens maker formula. So 1 by f1 is going to be equal to, is made of 3 by 2, right, 3 by 2 minus 1, and this is going to be r and minus r. See, always draw this diagram, otherwise we'll make a mistake, right. So the light is coming like this side is positive, this side is negative, right. So this r is falling on this side is positive, this r, in case this is falling on this side, this is negative r. Okay, so the lens maker formula, yeah, and this is mu, right. So our lens maker formula, I'll write it down, 1 by f is equal to mu minus 1 by r1 minus 1 by r2. Okay, so 1 by f, mu is equal to 3 by 2, right, for this lens, the convex lens, minus 1 by r minus 1 by minus r. Okay, so this is going to be 1 by 2 into 1 by r plus 1 by r. Okay, that is 2 by r, 2 will cut, so 1 by f1 is equal to 1 by r, and f1 is equal to r. Okay, so that is our first thing. Now let's write down the lens maker equation for the lens number 2, and let's see where we get from there. Now remember, we'll always draw our diagram. If we don't draw our diagram, we'll make mistakes, right. So this is our lens number 2. It has a refractive index 4 by 3, right, 4 by 3, and now here comes, this is negative side, this is positive side. Okay, so here comes our lens number 1 by f2, right, is going to be equal to 4 by 3 minus 1 into 1 by r, right. R is on the negative side, so minus r. Okay, minus, now this one is 1 by infinity. Okay, So this is 4 by 3, right? And so 3 minus 3 minus r sine f2 minus 3r. Okay. Now we know our f1 and f2, right? And now we have to write the lens maker formula for the lens number 3. Okay, now lens number 3 is again like this, right? But now we don't know the refractive index, right? So we'll write 1 by f3 is going to be n minus 1. Okay, is going to 1 minus r, right? This is on the negative side like last time, and this is by infinity. This is going to be n minus 1 by r, and it's going to be 1 by f3 with the negative sign. 1 minus n by r is going to be 1 by f3. Okay, now let's see what we have got, right? We know 1 by f1 plus f2 is 15 centimeter, right? Now we know the value of f2 and f1 as well. We can simply plug that over here to find the value of r. Okay, so that's what we'll do, right? So 1 by f1, f1 is 1 by r, right? And f2 is minus 1 by 3r, and that is 1 by 50. Okay, so with that, let's see if we can find r. So it's 3r. Okay, 3r minus r 15, then 2r 3r it's r. So this is 3 minus 1. Yeah, 2. So r goes on that side. 3r is equal to 30 and r is equal to 10 centimeters. Okay, and we know the f is also going to be 10 centimeters. Very good. So now with that we just have to come here, right? And we can simply find, if we know the f3 value, then we can simply plug in the number. We know n, we know r now, right? And if we know f3, we can find n, right? So f3 we can find from this equation, which is already we have written over here, f1 plus f3, right? So we can simply go here, 1 by f1 plus 1 by f3, and that is giving to be 1 by 25. F1 is 10, right? 10, 3, 25, 1 by f3 is 125, so 10, do that. So we have that 1 by f3 value over here. We bring that over here, okay, and put it over here. So 1 minus n divided by 10, this is 1 by f3. Minus 3 by 50. Five. Go on that side. Simply find that whatever number is 1.6, so 1 plus 0.6, and that is 6, and that is the refractive index we are looking for. Okay. So what is important is that because it's a complex system, right? So you have lens number one, then we change the refractive index of the lens number two. So basically we have three lenses, and the ray of light coming like this, getting refracted from this one, then this one, then this one. But if you can simply simplify the problem, if you know that, if the image is forming in the same place, basically the combined focal length of this system is going to be equal to that number, right? So we can simply solve that using that, and that fundamental. So now let's move to the another question. Okay. A plano convex lens is made of material of refractive index n. Okay, so first thing first, we'll draw our diagram. So we have a plano convex lens, okay, which is made of a material of refractive index n. We don't know what it is. Okay. When a small object is placed 30 centimeter away in front of the curved surface of the lens, an image of double the size of the object is produced. Okay. Now we have this u, which is given 30 centimeters. Yeah. And we know that an image will be produced which is double the size. Okay. So now let's look at the second part, which says that due to reflection from the convex surface of the lens, another faint image is observed at a distance 10 centimeter away from the lens. Which of the following statements are true? Okay. So this lens is basically acting both as a lens as well as a convex mirror, right? So in the second case, basically, some reflection is happening from this side, and then the image is formed for the same object, which is shown to be another faint away or a distance. Now, all it says is that double the size, right? It doesn't say which side it is, right? Is it erect or inverted, or what it is, right? So now it always helps to draw the ray diagram first, right? So that will give a lot of clarity while using the formulas. Okay. So if you don't do draw the ray diagram, basically you will get stuck, right? So always helps. Please draw the ray diagram before you proceed on a problem like this. Okay. So let's draw the ray diagram first. So if you remember the last problem, we drawn the ray diagram and we figured out that it is going to be perpendicularly reflecting from the mirror, right? So here is our, always try and draw the ray diagram. Here is our U. Okay. Go like this. Okay. Then focal length somewhere like this, converging lens. Second one will go from here, center, and now we have the object over here, right? We go like this, and then cut from here, okay, and a parallel ray we go like this, cut at the focus, and wherever these two ones will cut, right, that is where the object will be formed, right? Sorry, the image will be formed. So let me draw it clearly, because I failed to draw it very clearly this time. So yeah, so basically this is our lens. Okay, now this is the object, right? First ray will draw parallel, will pass through the focus. Okay, this is going to be F U. Second ray will simply pass through the center, which will go undeviated, right? Wherever these two will cut, the image will be formed over here, right? So we know that the V is going to be positive. If the ray of light is coming like this, this is positive side, this is negative side, and the U is given to be 30 centimeters, right? Yeah, 30 centimeter, and it says that the size of this image, right, the H2 is basically now double the size, right? So this is H2, and the H2 by H1, this ratio is 2, right? And we also know that it is going to be minus V by U in case of this thing, and V is going to be positive always. Yeah, so because it is inverted right here, so this this is going to be V by U, and because it is inverted, the magnification is going to be -2. Okay, so -2 is going to be equal to V, and U is negative, right? So U is negative here, -30. So V is going to be multiplication of that, and it is going to be positive, and 60 as expected. We know that The V is going to be on this side and this is positive, right? So it is going to be 60 centimeter from this side, right? And now let's look at the problem. We have all these things, right? So we find the focal length of the lens. And so first part, right? Let's do the first part. We know the U and V, so can we find the focal length? Yes. So our 1 by V minus 1 by U is going to be 1 by F. V is 60 plus, and U is negative, minus 30, right? And this is going to be 1 by F. So it's 1 by 60 plus 1 by 30. F 60, then it's going to be 1, it's going to 2, F 3 by 60, F, and F is equal to 20 centimeters. Okay, now the F is 20 centimeters, and since the focal length of the lens is 20 centimeters, so this is correct, right? Now can we find the refractive index of the lens? Yes, we can. We can simply use the lens maker formula because we now know the focal length, right? So 1 by F is going to be the refractive index of the lens is what we need to find out, n minus 1. First surface, assuming on this side, radius positive. Second surface is infinity, that's gone. And now let's see where we get from here, right? So can we find this? 1 by F is 1 by 20, and the n is 1 by R, right? We don't know n, we don't know R, so but we have one equation at least. Now with this R is going to be same for the convex part, right? So possibly you're going to use that formula to find that R, right? So this is now a convex mirror, right? And says that another image is formed at a 10 centimeters from here, right? From the mirror for this same image, same object. Object has been placed away, and then you have another image 10 centimeters away, right? Now the question is on which side? Is it going to be on this side or this side, right? So you have this object U, right? We know it is a convex mirror, okay? So for the convex mirror, it is always going to be image is going to be on this side, okay? It's always virtual, right? This is our 10, right? And so the ray of light is coming like this side is positive, this side is negative, right? And we don't know the R, that we can find. We know the U and we know the V, so we are going to simply write 1 by V plus 1 by U is going to be 2 by R, okay? The U is minus 30, and V is plus 10, right? It's 2 by R. Written it like this, okay? Sorry. So now it's going to be 1 by 30, and then going to be 3 minus 1, okay, by R, cut, plus 30 centimeters, okay? So now we know the value of R, which is going to be plus 30 centimeters. Can we check if we have that here in the options? The radius of curvature of convex surface is 45, so this is not true. We have found it to be 30, so this is gone. The front image is erect and real. We can never have an erect image from this concave lens. All we need to check if the refractive index is 2.5, right? So now with this information, we know the R is 30, and now we have this formula already written over here, and let's use that to find the refractive index. Okay, so we have now 1 by 20, it's going to be n minus 1, and R is 30 centimeters, so this is going to go on that side, so that will become 30 by 20, and it's going to be n minus 1, okay? 30 by 20 is 1.5 into n minus 1, and will be now 1.5 plus 1 is 2.5, and let's check if we have that correct numbers in the option. Yeah, so says that refractive index of the lens is 2.5. So the correct option here is A and D, right? And it is a multiple choice question, right? So if we get both the right, we score some marks, right? Pretty simply, the thing is that if you just proceed with the fundamentals, right? So always observe, you try and use your basic and fundamental equations as much as possible. Do not try to use formulas which you are not sure about, and simply go step by step, treating multiple optical system as a part of combination of different optical system like this one, right? So here we have one lens, and then it starts acting like a concave mirror in this case, right? Here we had like one, two, three, and then one, two, the two changes, and then the third one, right? But we simply use the basics to solve the problem. Here we have two surfaces with different refractive index, so we didn't use the standard formula. We proceeded with the basic refraction, and we were able to solve the problem, right? Here again we had two refracting surfaces. We used the first one, found the where the image was formed, and then used that as an object for the second one to find the solution. And whenever it is going to be parallel, right, so you can always find the focal length and things like that. Again here we had these two lenses in the optical system. We used the first one, found where the image was formed, and use the second one, that image as an object for the second one to basically find the solution. Yeah. So this is how you can simply solve the JEE problems. We'll be coming up with more problem sessions, and you should always try and solve as many problems as possible. Get your sign convention right. And if you want to watch more videos like this, you can go to deepdivephysics.com. Yeah, we also, or you can subscribe to our channel, and in deepdivephysics.com, when you register, we have a very structured playlist, so you can watch all the videos without any advertisement and so forth, right? We also provide one-to-one and small batches guidance. If you're interested in getting that, please get in touch, right? And we'll be happy to help. Thank you.